Now we will try to understand the pathogenesis of cholera. Now earlier there were many theories, but now this is the most accepted one. Now consider this as a Vibrio cholera, and this is our intestinal cell. Okay, and this is the mucosa lining over our intestinal cell. Now, as this Vibrio cholera approaches the mucosa of the intestinal cell, it starts releasing mucinase. Now, this is the first step, that it releases mucinase, and this mucinase, uh, like a like a warrior, passes through the mucin barrier, reaching our intestinal cell. Okay, as it reaches our intestinal cell, it has an adherence factor over it, and this adherence factor binds to the receptor over our intestinal cell. After this binding, the game begins. Means, as it binds to the adherence factor, the two toxins of Vibrio cholera are released, which do all the things that happen in the cholera. Means the L toxin, as shown by this small rectangle, and a H toxin, this one. So what happens is that this L toxin has a function that it binds to a receptor in the intestinal cell that is known as ganglioside, that is GM1. So L toxin binds to a ganglioside receptor over the intestinal cell, and then H toxin activates adenyl cyclase. Okay, so binding of L toxin to ganglioside and H toxin activating the adenyl cyclase. Now as we all know, this adenyl cyclase increases the level of CAMP, cyclic adenosine monophosphate, and this activation and increase in CAMP leads to activation of a ion channel, that is CFTR, cystic fibrosis transport receptor. Okay, we don't need to remember the name, just as ion channel. If we remember, this camp increase lead to activation of ion channel, which increases the excretion of chloride in fluid, and this leads to a watery diarrhea that we see in cholera. So this is what we needed to know about cholera pathogenesis. Thanks for watching.